We're going to talk today about reading a graph. We did this, I don't know if you recall, in the very beginning of the year, but you're going to do it again in the beginning of calculus. So I think it's really important to talk about this again. And I'm going to add a little piece to it, I think. So let's look at this graph here. It's crazy. It's got all these little pieces. Okay, so let's first talk about the domain. What is the domain of the function? So the domain of the function is the possible x values. So you want to start from the left and go to the right. So this graph does not point to the left. There's no arrow that points to the left. The very first thing I see to the left is this hole at -8. So how do I indicate that it's a hole? Well, I use a round parentheses instead of a bracket. If that was filled in, I would have used a bracket. So now let's go from left to right. There's a lot of jumps, but let's see if anything is actually skipped. Okay, so it starts at -8. I have points at -7, -6. Now there's a hole, but that's okay because that dot is filled in up here. And then it goes through all of these x values until -1. And I'm stopping at -1 because if you look up, the graph doesn't start again on -1. Now, does it equal -1 or does it not equal -1? Well, that dot down here is definitely filled in. So this is going to get a bracket. Okay. Where does it start again? Well, the next thing I see is this hole here. And that hole is at x equals 0. But again, it's a hole, so I'm going to need a parentheses. So starting at 0, goes over to the right. It pauses here at 4, but then it picks right back up at 4. So I actually don't even need to stop there. And then it goes on forever to the right. Okay. So there's our domain. Let's talk about the range. So the range is the y values. So the lowest y value, let me add this here. We're going to go from bottom to top. So the lowest y value is this dot here, which is at -5. Now that dot is filled in, so it definitely gets a bracket. And now let's just crisscross back and forth. Is there points on the graph? Points on the graph. Points. Yes. It's a little hard to tell, but none of that is skipped. There's no y value that's skipped as you go up. You know, there's a break here between 4 and 5 on this side of the graph, but that's covered on this side of the graph, just as an example. Okay. State the x values where f of x equals 4. Remember, the f of x is just another way to say y. So where does the function equal 4? So I'm going to just draw a horizontal line at y equals 4. That way it's easy for me to point out the points where y equals 4. So I think that's -4 for x. And then I see this point again over here. I think that's about 4.5. And then this point here, which looks to be about 7.5. Okay. Let's find the x-intercepts. Remember, the x-intercepts is where the graph crosses the x-axis or when y is 0. And now if we look here at the x-axis, this is definitely a point on the x-axis. This, however, is a hole. And I don't know if you remember this from the beginning of the year, but we called it emphasized nothingness. So they're just very clearly pointing out that there is nothing there. So that is not an x-intercept. How about a y-intercept? That's when it crosses the y-axis, right? But if you look, what's on the y-axis? another emphasized nothingness, a hole. So there is no y-intercept, and that's okay. Sometimes there aren't any. Okay, state the intervals where the function is increasing. Okay, this is really what I wanted to get to because you have to do this in calculus a lot. Now, oh, little typo there. So when you are answering an increasing or decreasing question, you must be looking at the graph from left to right. Okay, so you're comparing it left to right, and you're seeing where the graph goes up and where it goes down. So the y stuff is taken care of in the increasing and decreasing words, but your answer is in terms of x. Okay, so that's what this means. This always means in terms of x. Okay. And then likewise with the decreasing. What I like to do is look at the increasing and decreasing together. That way I don't miss anything. So I just start at the graph on the left. I decide if it's increasing or decreasing, and then I just put those little intervals in each category. So if I start way over here on the left, well, my leftmost point is actually not a point, it's this hole. So if I travel on the graph, am I going up or am I going down? I'm going down, so that's decreasing. What are those x values? Well, that's -8, but not a bracket because that's a hole. And then it stops at -6. And remember, these are x values. Really, the only time you give y values is if they ask you for range. That's just about it. Okay, so when we pick back up on the graph at -6 down here, and I travel on the graph, I'm going up to here. This is the top. So now that's an increasing section. So that's going to be parentheses because it's a hole, -6 to -4. Now the point at -4 is filled in, but the question is it increasing at -4? And it's not, because you're stopped at -4. So we're actually also going to give that a parentheses. And then after -4, when we travel on the graph, we're going down all the way to, when x is -1. So from -4 to -1, we're decreasing. So I'm going to come back over here to my decreasing, and I'm going to say -4 to -1. Okay, the next point on my graph is not really a point, it's another hole. So that's at 0, and this is increasing till x is 4. So that's going back in my increasing category. 0 to 4. Now, this, I would include 4 here because it stops. It's not flat there. That's a little confusing to you, I'm sure. But do you see how if you were standing on this point here, you'd be flat. You're at the top. But here, you're not flat here. This is not flat. You're on a hill. Okay, so let's come over to the next part where x is 4. That's a hole again, and we're going down till we get to x is 6. So that's a parentheses 4 to 6. Again, I'm not gonna use a bracket here because at 6 you're not down, you're already at the bottom. And then still going to the right, 6, and this is an arrow, so that's till infinity, and it's increasing, so that's 6 to infinity. Okay, find the x values of any local minima. So it doesn't have to be the absolute, just a minimum in an area. Okay, so let's look at, I would say let's look at each section of the graph. So if we look at this first section over here on the left, this is a minimum in his area. I would say that -6 right here is a minimum in his area, but that's a hole, so you can't count him. And then the function is increasing, so these are not minimums, right? I mean, this is a max, really. This is a min. And then we travel on the graph, and then we get to a low point. So there's another minimum. Now we hop on the graph again here, and I would say this is a low area because I'm going up after that, but this is not a point, it's a hole. So that doesn't count. So then I get to 4, and I've walked up all that time. So this is a max. I get to the next section of the graph, but there we go with the hole again, so that doesn't count for anything. So we travel on the graph to 6, and we get to a low spot. And then we travel again on the graph, but this goes on forever without stopping. So if it doesn't ever stop, there's no maximum. So let's make a list here. X values of minima. I've got this one. X is -6. Remember, we're using X values. I have this one at -1. I have 4. Oh, nope, that's a max. So sorry. Apologize. That's a 6. There we go. And for maximums, we have X is -4. We have X is 4. I only see 2 maximums, this one and this one. And remember, we're giving the X values. Okay, let's see. I'm going to add a little piece here. Find the X values or X value of an absolute minimum. So is there a point on this graph that is absolutely the lowest point on the graph? Yes. It's this point. There is no point on the graph that is lower than that guy. And he's at -1. So then he is an absolute maximum. So a local, oh my God, I said maximum, minimum. So a local is a minimum or maximum in an area, but the absolute is like in the whole graph. How about, is there an absolute maximum? Well, let's look here. Doesn't this graph go up forever? Then how could we say there was an absolute maximum? Because if I travel on this graph, I will always be going up at the end. So there's no absolute maximum. Okay, state the intervals where f of x is greater than or equal to 0. So remember, f of x is just y. So the intervals where y is greater than or equal to 0, this is just code for above or on the x-axis. But again, we're going to give x values. So let's get rid of this because I'm making a mess. And let's highlight all of the stuff that's above the x-axis. So this, it's actually above or on, so I'm going to color this one in. All of this, and all of that. Okay. So I'm going to start at -8, but I'm going to go round parentheses because that dot isn't on the graph. And then it goes to -6. But then doesn't it just pick up at -6 again? So I'm actually not going to separate that. So it's above or on the x-axis until -2. And then I have to stop because this blue stuff is below. So then I start again at 0, but I don't include 0 because that's a hole. and then I go to 4, but then I pick back up again at 4, so I don't need to stop. Sort of like we did with the domain, like we never stopped between 0 and infinity. So I can just keep going, and it points up forever, so I can just say infinity. So now the stuff that's below the x-axis over here, now that's not an equal to, so this is just below. That's just only this blue section here. So that's going to be from -2, but round, because we're not talking about when it equals 0. And then to -1. But that gets a bracket because -1, that dot is totally under the x-axis. Okay, these ones are not so bad, but yeah, you know, people still got them wrong, so. F of -6. F of -6. F of -6. So let's go over to x is -6. Where's the dot? The dot is here. This is emphasized nothingness, so that does not count at all. So the value of f of -6 is 5. F of 0, well, at 0, there's only a hole. There is no point on 0 where x is 0, so this is undefined. Okay, the other thing I would like to talk to you about with this graph, which will definitely help you for the beginning of next year, is the idea of limits. Okay, so we're going to say, so this graph is f of x. So let's look at this. The limit as x approaches -4 of this function. So where does x equal -4? Well, here, right? On your graph, x equals -4 right here. And that value is at 4. So the limit as x approaches -4 of the function is just the number 4. Notice that the answer was a y value. So the answer to a limit is a y value. It's very important. Okay, let's try something a little different. Let's say the limit as x approaches +4. Well, here's the problem with that. As you get close to x is 4 from the left side, I'm getting to this number. But if I was traveling on the graph in the opposite direction, I'm getting closer to this number. And that's not the same number, is it? So if I'm traveling on the graph from left to right, I get to 3. But if I travel on the graph from right to left, I'm getting close to but not equal to 5. So if you don't approach the same number from the left as from the right, then this limit doesn't exist. Okay, you have to approach the same number from the left and the right. Well, what if somebody wanted to know that? We add that little guy. And what that means is literally from the left. So as you approach 4, from the left. And then we'll do it again, from the right. That's what that plus means. Okay, so from the left means from the negative world. So we're traveling on the graph, and as we get to x equals 4, we're getting to y equals 3. As we're traveling on the graph from the right, so right to left, as I get close to x equals 4, I'm approaching 5. Now, I know that there's no dot at 5, but a limit is not asking you where the actual dot is. They're just asking you what you're approaching. But if this number doesn't match this number, then the limit with no plus or minus right up here doesn't exist. How about, let's talk about 0. The limit as x approaches 0. Well, I can only get to 0 from one side because here's where x is 0. I can only get to it from the right. I can't get to it from the left. I never approach that number from the left. So I could say I approach it from the right. And what's the y value as I get to x is 0? It's 1. And I know there's a dot there, but that doesn't matter because a limit is not a definite value. It's just what you're approaching. It's literally what are you approaching. How about the limit as x approaches, -1. Okay, so here's -1. Kind of like with the 0, I'm only approaching -1 from the left. I can't even get to it from the right. So I would have to put another little negative up here to say from the left. So as I approach this x value from the left, what's my y value? -5. Okay. All right, so those are some things that I want you to be able to do before you get to calculus, because you're going to have to do that again when you start, and you'll just make your life easier if it already looks familiar. So I hope that you'll try the homework problems, and I'll see you next time.